Hey everybody, I'm Marcus Hazelwood, and welcome to Clear Haze Exchange. I'm an energy engineer with over 15 years of experience in sustainability and energy efficiency consulting. Many find these topics a little complex, so I created Clear Haze Exchange to help provide clear, actionable insight, clearing the haze, so to speak. We'll cover plenty of topics under the umbrella of energy efficiency and sustainability. Let's get into today's conversation. Welcome to Clear Haze Exchange. Today's guest, we have Alison Farmer, who is a former research astrophysicist who found her passion in making the built environment more energy efficient and sustainable. She is Labs2Zero's Program Director at International Institute for Sustainable Laboratories, I2SL, where she leads efforts to cut energy use and carbon emissions in some of the world's most resource-intensive facilities. As Secretary of I2SL's Board of Directors, Alison plays a key role in shaping tools, strategies that help universities, research centers, and biotech companies take practical steps towards decarbonization. With experience on both consulting and lab owner side, she brings a grounded, hands-on perspective to her work. Alison studied physics at the University of Cambridge and earned her PhD in astrophysics from Caltech. Alison, welcome to the show.
Hi, Marcus. Nice to be here.
Yes, there's a lot of exciting things to talk about specifically with I2SL that we'll get into that I'm looking forward to. But just to really start off the conversation concerning labs, you have a deep background in data and pulling together large data sets. And of course, your background in astrophysics. For labs, which are some of the most energy intensive buildings, what is one surprising thing that you've learned about labs in your work?
Yeah, interesting question. So I was thinking about when I got started working on labs. And I think for me, one of the biggest surprises was just how many different people, how many different stakeholders are involved in every single decision, in every single project about lab facilities. There's the occupants who have very specific needs for their research. There are lab managers, there's EH&S, there's facility staff, building managers, sustainability and energy efficiency staff. And there's just really so many stakeholders who need to have a say in everything that happens in the lab building. And I think for me, that was a huge surprise when I first started getting into lab facilities, perhaps compared to astrophysics, where there are just, fewer people involved in general. So that can certainly be pretty daunting at first, because it means making sure that the project works with all of those people and everyone's okay with it, everyone's on board. But the other side of that is the great thing is that, when everyone in those groups works together, you can achieve great things and you know, implement really great projects. I think that was my biggest surprise getting started on lab
Yeah.
facilities.
And I remember back when I was working at Harvard University, I think you were at KW Engineering, but you were collecting data back then. I think you did some research at Harvard as well.
And yes, yeah, way back in the day, I was a postdoc at Harvard for 5 years in the astrophysics department. Yep.
Yeah. So, really, what drew you from astrophysics into energy engineering and lab sustainability?
Yeah, so it wasn't just that I woke up one day and decided, oh, hey, no more of this astrophysics stuff. Let's just do energy engineering. It was a, protracted period of soul searching there where I was trying to figure out, where my passion really lay. I did love doing astrophysics. I still love astrophysics. Whenever I was involved in projects, I would put everything into it, be really excited about every project that I was working on. The trouble was at the end of those projects, when I finished a project, I couldn't answer the question, what do I want to do next? What question do I want to answer next? And for me, that was a problem, something telling me like the motivation was off there. I loved the work I was doing, but like there wasn't a big question I wanted to answer. So I spent a long time towards the end of my postdoc time trying to figure out what it was I did want to do. And I ended up in energy engineering in buildings by just kind of trying some things out. I wanted to be useful fundamentally. Astrophysics is great for many things. It's not sort of useful in any practical, immediate way. And I felt, I really needed to start seeing immediate results from my work. I started trying a few things out. So I spent some time weatherizing houses as a volunteer project. I audited some energy technology classes at Harvard, where I was at the time. And then I read this book called Sustainable Energy Without the Hot Air. It was by David Mackay. It's a book my dad happened to have read and passed me. And I thought that book was amazing, and it just really inspired me. I wanted, made me realize I really wanted to get involved in energy and in buildings in particular. So it was sort of a combination of things, and it was months and months in the making, but that was the journey.
Yeah, that's good. How did those experiences, particularly the ones both at Harvard and Caltech, shaped your approach to data-driven solutions? Because as we're talking about these areas of expertise, there's a lot of data, and so how did those experiences from the educational side shape your approach to data-driven solutions?
Yeah, I think anyone who's raised in science loves data and loves dealing with data. Obviously, developed a lot of skills around data as part of that process. But one thing that's sort of funny about the shift from astrophysics to engineering in terms of data is this, and it's sort of embarrassing to say it now. When I first moved from astrophysics to engineering, I treated everything like an astrophysics project in the sense that I would see these systems, I'd be getting data from them. I would just sit there and watch it and wait for the systems to get to like the situation that I wanted, the state that I wanted. Because if you're looking at stars, galaxies, planets, you can't change that. You just get what you get. You watch it. And I sort of at first treated engineering projects in the same way. And then, over time realized you can actually change things. You can do tests with these, you can influence them. And if you want to see what it does, if you change that thing, you probably change that thing and just test it. So that was a really big shift for me. And a really big shift in terms of the types of data that you could get. You don't just have to sit and wait for what the universe gives you. You can really change things. So yeah, it is a little bit embarrassing to admit that now, that was like a big sort of philosophical shift I had to make in my approach to work coming from astrophysics, but that was one of the big challenges. The other big challenge was actually the units that we use in engineering. Coming up through science, it was all metric units the whole way. And then, you come into engineering and you encounter US units, imperial units for various things. And that was another big challenge to come to terms with that.
Yeah, and I know with other parts of the world being invested in different metric system, did you deal much with data and then converting in terms of your research?
Yeah, well, in research, it was all metric, but in within I2SL and the lab world, we are the International Institute for Sustainable Laboratories, of course, and so we do offer our programs globally, and so we do a lot of unit conversions. So, for example, the lab benchmarking tool, which I hope we get to talk a little bit about in
Yeah.
a while, is fully internationalized, and so does work in both systems of units. Another like secret skill I have is being British. You're kind of in the middle of the different unit systems. In Britain, people are pretty good at converting between the different systems just because there's been a sort of general transition over the last maybe 40 years between using the old imperial US units to using metric units. And so I think that's another sort of secret skill there is making those unit translations.
Yeah. Yeah, that's good. So what motivates you most about the lab decarbonization today? Because you talked about how you want to be useful. And what is the biggest kind of motivator around this lab decarbonization?
Yeah, well, I just love working in this field. I love working on labs. They're the most interesting buildings out there, in my view, and some of the most energy intensive, carbon intensive buildings out there. And, working with I2SL, I get to come in contact with some of the most exceptional people in that field. And I see their continued energy and drive to do better. And, that really drives me to do better too. So I think that's what keeps me in this field is the fact that we have this really strong community of experts working on the most interesting buildings that are out there.
Certainly, certainly interesting. Just for the audience, the familiarity, the first thing I think about when I was introduced to the Lab 2 tool, which we're going to get into next, I think about Energy Star. Everyone's familiar with Energy Star platform to an extent. It's helpful and useful and when you're looking at office spaces, but then there becomes limitations when you get into college universities with mixed use and particularly lab types use. And because of the broad different, type of lab use and research type within those facilities, this is kind of where the value and what I was really excited about and being a part of the development of this tool is giving companies, organizations, and even universities the opportunity to utilize a benchmark. And so with Labs2Zero, the Labs2Zero program, it's targeting and giving organizations and research facilities the opportunity to go from one benchmark to look at how they can be better. If you don't have a baseline of how your performance is, then it's hard to look at what's a better performance. So, what is Labs2Zero and why was it created?
Sure. Yeah. Well, that was a great introduction you gave already to Labs2Zero, but I'll give you another one. So Labs2Zero is I2SL's flagship program for reducing energy use and emissions of lab buildings. And we created Labs2Zero because, as you mentioned, there are so many gaps when it comes to the landscape of energy efficiency programs regarding labs. Often they just kind of fall through the cracks. They fall into this catch-all other facility type that's really just means we don't know anything about it. As you mentioned with Energy Star scores, there's never been an Energy Star score for lab buildings. There are for many other building types, there's just not for labs. And so you couldn't do that quick kind of automated benchmark of lab buildings that you'd want to just get a sense of the performance of your building. So we wanted to fill in some of those gaps. And then in addition, we want to take it beyond just benchmarking. So the program, as well as including benchmarking tools, includes additional tools that help you take the first steps on your journey towards saving energy, reducing emissions in lab buildings. And that was really important to us, that we include not only how to assess where you are, but also help you get started getting somewhere else, improving performance as well.
Yeah, that's good. Excellent tool in the construction and design industry, whether it's a renovation or new construction. We have to be able to see in design what we're moving towards, and those goals are critical. So what makes laboratories different from other building types? And you kind of touched on this already, but when it comes to energy and carbon specifically.
Yeah. So labs are different in a few important ways. So, of course, I think as we all know, they typically have higher energy intensity than many other types of facilities. Canonically, we say 3 to 5 times. Some people say 5 to 10 times. It depends on the facility. Much higher energy intensity than your typical office building, though. With lab buildings, also, there's, as I mentioned at the start, actually, there's more stakeholders. There's more involved in doing any project to reduce energy or emissions in the facilities. Then there's the fact that it's not a monolithic category of buildings. Lab buildings are different from other buildings, but they're also very different from each other. It would be unreasonable to compare like a physics teaching lab on one hand with like an intensive chemistry research facility on the other. It just wouldn't make sense to do that, comparing energy use intensity or anything else. And so I think that's why labs haven't been addressed by a lot of those other programs, because it's a very diverse category, even though there's a lot of opportunities there. And then also, you need a certain level of experience with lab facilities to be able to go into one and make recommendations about the right kinds of energy efficiency measures there. So if you have somebody who normally does energy audits of office facilities or schools, they're not going to see the things in lab buildings that are really going to make a difference. And most often that's things around the ventilation system, where you've got to have a good grounding in what is normal for lab ventilation, in what safe levels of ventilation, what that even means, how you would go about optimizing the ventilation systems in a lab facility. So I think that's where a lot of the challenges come from with energy projects. As regarding emissions, you know, lab buildings are not as different in terms of emissions. Of course, they have higher emissions intensities because they've got higher energy use intensities. And, there's a couple ways, if you look at supply chains and so on, you could certainly consider their impact to be higher in terms of emissions. But the thing that we're really trying to get at with the Labs2Zero program is just that energy consumption of the lab buildings. And then that is going to reduce the emissions associated with the buildings themselves.
Yeah. And how does Labs2Zero help organizations make measurable progress? How specifically do we see organizations given the opportunity through this tool to make measurable progress?
Yeah, so we have a few ways already that organizations can use Labs2Zero to track their progress and start to make progress. So, for example, our benchmarking component is one of those. So, we currently have, for any building that's entered in our lab benchmarking tool, we will give them 2 scores. We will give them an energy score and we'll give them an operational emissions score. Well, those scores are weather corrected so that if you get a score for different years of data, you can use that to track your performance over time, as well as just to see how you stack up against other buildings today. So just for reference there, our scores work a lot like Energy Star scores do, and we modeled our score development on the way that Energy Star developed theirs. So if you get a score of 70, that means that your performance is nominally better than 70% of the lab buildings out there, or, more specifically, the lab buildings in our pretty extensive database of lab building facilities in the lab benchmarking tool. So certainly, that's a way to measure your progress over time. And then the other piece that we recently added was this AIM report, which I think we'll talk about in a little bit, I'm sure. But so the AIM report is our next step to take you beyond just benchmarking, and it's identifying, how you can truly move from the score you're at to a better score that you might want to target.
And yes, absolutely gonna talk about that aim. But before we get there, so I mentioned that our first interaction was when I was working at Harvard and you were collecting data. So could you touch a little bit on the importance of, or really the value of the database you're using? The reason Energy Star is so valuable is because of the massive database of similar buildings. But in order to build a tool like this, you have to build a strong database, because you're comparing a lot of different use types, and a lot of specific lab use types. So how does this data um, come into play on this benchmarking tool?
Yeah, well, the data has really been key. You hit on that perfectly there. So we started collecting data in the lab benchmarking tool, or in its previous incarnation, way back in 2002. And so we've been collecting data pretty consistently over more than 20 years. At this point, we've managed to collect data on more than 1,300 lab facilities that are now in our database. And that's more than 200 million square foot of lab building space. We estimate that, considering that most of these buildings are in the US, although not all of them because the tool is internationalized, most of those buildings are in the US. We consider we have something like 5 to 10% of the total lab building population of the US is in our tool. And so as a database against which to compare your buildings, that's huge. That's a really useful resource. And so people have always been able to go to the lab benchmarking tool and look at that data set. So it's anonymized. People enter their data there. We anonymize it. We do some checks on quality, and then we allow other users to search that anonymized data set. And people have always been able to go there and try to find peer groups for their buildings so they can benchmark their performance in a meaningful way. And for labs, that's super important because, as I mentioned, there are lots of differences between the functional requirements of different lab buildings. And so you have to make sure you're comparing like with like. Now, once we get a large enough data set, what we're able to do is something very like what Energy Star did, which is to do a statistical analysis of that data set to say, hey, where are the correlations here? What kinds of buildings seem to be consuming more energy? What difference does the amount of lab space within a lab building make to the energy consumption of that building? And so we're able to find those correlations and then able to come up with a scoring formulation, same way Energy Star does, that adjusts for that. And so basically, when you get one of our scores, you're effectively comparing yourself against all the other buildings in the data set without going through this manual process of filtering and kind of iterating to find your peer group. So that's where the data has been really, really important. And so it's been great to get data from out there in the industry. People these days, it's like sort of this virtuous cycle that happens now. People are submitting their data to the tool to get their scores, which then gives us more data, which then will help us improve the scores in future because we'll have more data in our data set.
Yeah. Yeah, the value of having that data, as you mentioned, to support anyone using the tool to inform them about how they're using energy. Could you share kind of an example or early success stories from this program?
Yeah, actually, so that relates precisely to the data we've been getting in, actually. So it's a nice segue. So, as I mentioned, we have been collecting data from people for more than 20 years, and at some point we had enough data to develop our score. After we launched the scores, we saw a lot more people using the lab benchmarking tool, which was great. It means people want to see what their scores are. That's what we were hoping. So that was really gratifying. And we were seeing people using them for corporate sustainability reporting. So external reporting, internal reporting. We saw consultants using them as part of their study reports about buildings. We've seen people using it for GRESB reporting on the commercial real estate side. So lots of great uses of the scores. But what that also meant was that as people put their data in, our data set got bigger. And it also got more recent. Like we got a lot more really recent data and higher quality data than we've been able to use before. And so what we were able to do this year was to take that new data, make some more stringent data quality cuts, and do a new analysis to improve the scoring formulations. So we've got those new scores that we've developed. The previous ones were released as pilots like 1 and 2 years ago. So we've got the new version 1 scores ready to go, and we're going to be launching those probably end of this year or beginning of 2026. So it's been really nice that we've been able to deliver a tool that our industry is interested in using and is using. And then we've also been able to improve the tool thanks to their increased use of the database and the scores.
Yeah, and just to add to the value of this, that I've actually experienced a project I worked on where it was a renovation at a university for a lab space, and being able to take that tool and take the energy data, look at how the building's performing as is, and here's similar buildings that have this type of lab use, and this is how they're performing. So for the renovation, we know what we're targeting now and how much better we can get to that average. So it's certainly a valuable tool from the early stage design. We can evaluate by using energy per square foot and how much we can improve to show that we're actually saving from that initial capital investment. I've always been a fan of this tool and being able to utilize it in terms of design to show an owner, a client, or even architects, the engineers on the team where we can orient our efforts and target the efforts in design.
Absolutely.
So with that said, let's taking this a little bit step further, like to jump into the AIM report, which is another add-on to this tool, and I'd love to understand where people can see the value that this brings. So what is the new AIM report software, and who is it really designed for?
Right. Yes. Well, I'm glad you asked. We're very excited about the AIM report because after a year and a half of development of this tool, we just launched the first official version in August. So it's now available on our website and more specifically via the lab benchmarking tool, as you mentioned. So what the AIM report is I2SL's brand new automated energy audit software for lab buildings. And it's really designed to be used by anybody who needs to build the business case for energy efficiency in lab facilities. It's not intended to be limited to those who are experts in HVAC or energy modeling or anything like that. It's designed to be a very approachable tool to use. It's also quick to use. We also, when we were developing this tool, very much had in mind that this needs to be unbiased, right? Because we don't want these calculations to be coming from any one person, any one group. What we're doing is we're showing what's possible for buildings in a very objective way. So to that end, we developed it with this huge network of volunteers from our I2SL community. So as we were looking at what to go into the calculator, we had 4 different technical advisory councils looking at different aspects of that, with experts from across the lab community helping us decide what to include in our software, which measures to include, what to highlight, and so on, what the likely implementation costs would be. So that was a very important thing for us as we were developing it. Now, what we ended up developing was this energy audit tool. And so what it does is it takes the data that you enter in your building in the LBT, the data on your building, and then in the background, it creates an energy model of your facility. So if you've ever used the LBT, you'll know that to get a score or to get a benchmark, you don't need to enter that many pieces of data. And so the really cool thing that AIM does is it fills in a lot of the gaps about your facility based on what would be normal for a facility of that type, given what you've told AIM or LBT. It fills in gaps based on other things you've told LBT about the facility, and it makes this series of assumptions about the facility that makes it possible to create that energy model of it. And then with that energy model, AIM runs a whole library of energy efficiency measures on your building and then shows you estimated savings and costs specific to your facility. And then you're able to essentially choose your own adventure. What you start doing is picking energy efficiency measures that you're interested in looking at for your facility and putting them in a package. And so you can keep adding more and more measures to this package. And the really cool thing is that AIM knows all about the fact that measures in lab buildings are interactive. It's all about the ventilation, not all, but
Yeah.
many of the measures are about the ventilation. And so quite often when you see your classic energy audit report, you'll see a whole bunch of measures just kind of presented side by side, but you couldn't do all of these projects together because they're impacting the same systems. You'd be double counting savings. It wouldn't make sense. But AIM takes all of that into account. And so that's why I'm talking about it like it's choosing your own adventure. You're choosing your path through these measures. And every time you're adding another measure to your building, it's considering the other measures that are already in your package. And it never double counts. It never double counts on savings or on cost. And so what you end up with is this package of measures that you've selected. They've got estimated savings, custom calcs for your buildings, estimated implementation costs, also custom calcs for your buildings. It'll then also show you a set of case studies that are relevant to that package and your facility. So we've also got, as well as our library of measures, we've got a library of case studies, and the tools select case studies that contain measures that are like the ones you put in the package and facilities that are like the ones that you've got in the LBT. So at the end of all that process, you have a lot of information at the level of kind of an ASHRAE level 1, right? This is scoping study. This is not, investment grade, full project design sort of thing. This is scoping study, help aim you in the right direction, we like to say. And then you can export all of that as a PDF report that you can then share with management or whoever else at your organization that you're looking to build the business case with. So there's a lot in there. AIM
Yeah.
does a whole lot of stuff. We're pretty excited about the tool. We do see that there's a lot of different types of groups who are going to be using AIM. So for example, energy managers at an organization might use AIM to help prioritize attention between different possible measures at a given facility, or perhaps between different buildings in their portfolios. Which one is likely to have the best savings potential? We would see energy auditors and consultants who are already using scores. We would see them using AIM as part of their consulting offerings and then building, further project development around that. We could imagine that equipment vendors are going to use AIM because it gives this unbiased calculation, this unbiased estimate of what the measures they're offering are likely to save. And then also utility companies, they're always out there looking for opportunities of projects to incentivize in lab facilities. So they could certainly get a lot out of using AIM on their customers' facilities. So we are really hoping for a broad user base with AIM. Because I think it's something that it's very approachable tool, and it's going to be a very easy way for people, particularly if they've already got buildings in the LBT, a very easy way for people to get fast results on what's possible for their lab facility.
Yeah, that sounds incredible. The LBT is Labs benchmarking tool for anyone that is confused. I wanna just spend a little bit more time on the thought process with the value of being able to do a high level energy audit and understand what the needs are eliminates so much work in the beginning. And what I really like about this is you can take a high level look using actual utility bills and start thinking about, okay, where are the problems, where are the challenges, what are the likely needs for solutions before even a more detailed audit. So that is incredible value. And then like you said, you're linking this to data that you've already gained from the benchmarking tools. That's really exciting. Are you seeing a lot of energy managers and organizations? Like, what are you seeing in the beginning stage of this? People, whether interested in it, or what are they saying about the use of this in terms of practical and easy to use?
Yeah, so we've gotten some feedback so far. Of course, we didn't launch this a very long time ago. We did run earlier in the year a pretty extensive pilot with about 20 different members of our community who tested out the tool before launch. So we also got their feedback on the tool, and I can kind of combine that with what we found from the users so far since launch. And people are saying that it is very intuitive and easy to use. Much like the lab benchmarking tool, there's not a lot that's complicated about it. We have had a lot of interest from energy managers so far. And I think a lot of that actually comes out of some of these workshops that we've been running. So one of the things we've been doing, we have this training class. It's a 3-hour hands-on training class to using the LBT and AIM. So in that class, everyone in the class gets the opportunity to work on their own laptop and work through some example buildings with the LBT and AIM. And we're finding that the people who try it out in those classes are really excited to then go use it on their facilities. So what we want to make sure is we get as many people as possible being able to try it out. Because I think, I can say as much as I like about what it does, but it's when you actually try to use it on your building and start, adding measures, changing parameters, seeing how it affects everything, that you really start to see the power of it and you really start to think about the possibilities of what you could do. So I would definitely encourage anyone who's thinking about it to just try it out. On the website, we do have a demo version that is free to use. So absolutely, please give it a go.
And so how does it connect with that benchmarking tool? If you could explain a little bit more.
AIM is hosted by the lab benchmarking tool. So the AIM report lives on the LBT website. So if you already entered buildings in the lab benchmarking tool, you sign up for the AIM demo or the full version, then you'll start to see a button next to those buildings, next to the data entries that will just say, create an AIM report. And it's as simple as that. You click the orange button and you move into the AIM report software for those buildings. This was really important to us because we know that we have many thousands of people who've used the LBT over the years, and we wanted to make sure that we built this into the same platform that we use for the rest of our tools and our scores and so on. And it's also a really nice way to do it because people have put in kind of minimal data into the LBT. We have more than 100 fields you can enter, but frankly, they're not all mandatory and people don't do things that aren't mandatory. And so probably for each building, we have like 15 pieces of data that people have entered. And then the question of, well, what can we do with that data, with only that data, and try to create something that's already going to give really useful results in terms of an energy audit? That was the problem we were working with, and that's what we wanted to achieve. And I think that's what we accomplished. When you do enter the AIM report from LBT, AIM will show you all of the assumptions that it's made about your building. They'll have a little yellow tag on them saying that they're assumptions. And if you have better information, if you do know that fact about your building, you can edit it, you can change it, you can tweak it. And what that does is it means that the energy calculations then will be more accurate for your facility. But even if you don't know those things, you already get results. It will already show you, look, based on what you've told us and what is a reasonable assumption, an intelligent assumption for your facility, here's what you'd expect to save in the following measures.
Yeah, that's good. So we know the tool functionality, but what specific benefits would be appealing to someone like a facility manager or owners or researchers?
Yeah, so this would be more directed towards the facility managers or the owners who will be using a tool of this type. It's really just about the speed and the ease with which you can get to some answers about what's possible in your facility. So, as I mentioned, you can take a deep dive within one building and look at all the different measures that you could possibly implement in that facility. And you kind of triage using AIM, right? Maybe it turns out that building doesn't have a lot of high fume hood density spaces. Well, AIM will show that. AIM will show you that you're probably not going to save a lot of money, energy, looking at fume hoods in that building. But it'll show you other things that would probably save more. So you're able to quickly focus your attention on those things. You can also look across your whole portfolio. Maybe you're interested in looking at one measure across 10 buildings. If you've got them all already in the LBT, that's going to be a very quick thing to do to get these ballpark numbers for not only potential savings, but also potential costs. And of course, ROI and everything else for implementing those measures. So I think that's really the thing. It's just if you want to get answers quickly on what is possible in a lab facility and what it's likely to save, what it's likely to cost, then AIM is going to be able to do that for you very quickly. So LBT, for example, to enter the minimum data, assuming you've got basic data like how much energy your facility consumes, how much lab space there is, some of the basics on your building, what type of lab space it is, you can enter your data in LBT and get the scores in 10 minutes. It does not take long. And then if you've got AIM, you can enter AIM, you can start looking at measures there, and it's going to be another, 10, 15 minutes, and you've got an audit report. So obviously, this is scoping. This is not a replacement for full design and project development. What we're hoping is that what AIM does is catalyzes more of that, right? If people are able to quickly see what's possible, then more people are going to talk to, their managers, get some funding. They're going to hire a consultant to do more project development, and then more projects will happen to help reduce the energy consumption in lab buildings. So that's what we're
Yeah.
hoping for with AIM.
And I certainly see the value from an owner's perspective. They can look at this and have enough data to when they pick their consultants, they can understand enough about their building and what potential they have in order to hold them to it. Owners are able to look at the data and have a solid idea of what to expect and what to evaluate their engineers, gaining knowledge enough to be dangerous and to make good selections on designers. So, how do you see the AIM report shaping the future of lab decarbonization efforts? A lot of organizations, and particularly schools, have climate action goals, reducing decarbonizing. How do you see this AIM report shaping the future of lab decarbonization?
Sure. So I think, if we see the adoption that we're hoping for of AIM, then, the expectation is that more projects to reduce emissions, energy consumption will be initiated in lab facilities. And so, for one thing, it'll be easier to meet some of those goals. For the other, I think it's as these organizations are setting up those action plans, those goals, if they're looking to map out some of the potential pathways that, of their building energy consumption, then AIM would be a really helpful tool to use as part of that planning process. You can say, okay, we've got these 10 buildings. If we implement, the following 3 measures in every one of these buildings, what could we expect in terms of their energy use intensity? And then you kind of factor that into, those projections you see for like, here's where we think the buildings are going to be able to be under the following circumstances with the following initiatives in place. So I think AIM could be an incredibly useful tool as part of that planning process for what could be possible for reducing the consumption of buildings.
Yeah, that's good. That's good. So, what makes the I2SL community so important for this work? Because, as you mentioned, the more involvement, the more people adding to the program, it increases the value. So, what would you say is important about the I2SL community?
Well, the thing that's always great about the I2SL community is our diversity. So there's no other place where all of these different stakeholders from the lab world come together. There's nothing quite like I2SL. So, we bring together this community of experts from all across the lab industry, like designers, so, the engineers, the architects, other consultants, EH&S personnel, lab managers, researchers, sustainability, energy professionals, real estate professionals. The list goes on. And we see people from, academic institutions, corporate backgrounds. We see them from government facilities. We just kind of encapsulate everyone in that lab field. And that's been great for, as I mentioned a little earlier, the development of Labs2Zero and AIM, where we had these big technical advisory councils bringing together these diverse expert views from across our community. And it's also just what's really been at the core of the strength of I2SL over its, more than 20-year history.
Yeah, makes sense. We have the I2SL conference coming up, which I'm excited to be a speaker in a session early in that conference. I'm looking forward to that. What are you most excited about for this upcoming I2SL conference?
Well, of course, seeing your presentation in that session on Monday. But other than that, there's a lot of great things about the conference. So one of the things I'm really excited about is the chance to meet up with some of our volunteers. Over the course of the whole year, we work with these Labs2Zero volunteers from our advisory councils, like virtually. We have many, many meetings. And at the conference, we bring everyone together on the Sunday before the conference starts for in-person meetings where we do some deep dives into like focused topics to do with the program. That's one thing that I'm really looking forward to because we always get a lot of really great ideas out of those meetings. So that's a big thing. And then, it's always another thing I love about the conference is just the opportunity to catch presentations on things that I don't personally work on that are not my area of specialty. It's just great to be able to go and catch something that's from a whole other area of lab sustainability. So I'll need to look at the agenda and make sure I make it to a few of those sessions too.
Yeah, looking forward to that for sure. So, if labs want to start decarbonizing now, what's one step they should take first?
Um, well, I think you know what I'm going to say about this. First, come to the I2SL conference. That's the place to learn about all what other people are doing in that area, and to meet the experts that you'll need to help you implement that. And then the other thing is get your buildings into the lab benchmarking tool, get them some scores, use the AIM report on those buildings to see what might be possible, and help you form that plan for how you're going to get to where you need to be for that, decarbonization effort.
I absolutely agree. I think this is an excellent tool. I've always been always been an advocate for it, and continue to be. But looking forward 5 to 10 years ahead, what changes do you expect to see, and how in how labs operate?
Hmm. Yeah, it's an interesting question. And I think I would take that back to the question of data again. So I think we have a lot of data from all of our lab buildings that in many cases just isn't really being fully used right now in all of the various intelligent ways it could be used. And, for example, I'm talking about monitoring based commissioning, analytics, fault detection, all those sorts of things. What I'd love to see over that time period is more widespread adoption of that, just using what is coming back to us from our facilities so we can make more intelligent decisions about what to fix, how to operate them. We can just know what's going on a lot better in our facilities. That's actually one of the things that we're going to be adding to the next version of the AIM report. So right now we've got 26 very important measures for lab buildings. But in the next set we're going to be adding, we've got a bunch of measures that relate to recommissioning, essentially. So we've got monitoring-based commissioning, recommissioning, essentially fixing things that aren't working quite per design in the building. So I'm really excited about adding those as measures to the AIM report. And hopefully we'll see a lot more adoption and use of those amazing tools over the next few years. Because, I mean, for all buildings, they can give you useful information. But then for lab facilities, there's just so much you can do. There's so much data coming in. There's so many different places you want to be comparing data from. There's a lot of really great performance metrics you can identify to just track the performance of that building over time. That's something I'm excited about seeing more of.
That's good. That's good. Well, I really appreciate your time. This was a really good conversation. I think it's critical for people to be able to understand the tools that are available to advance efforts around decarbonizing buildings. It's not just decarbonization; it's business case, and this is a tool to further validate the return on investment from a business perspective, and also environmental perspective, and also a people perspective. So the three pillars kind of fall in place with this tool. This is an accessible tool, just like Energy Star. Anything else you would like to note in talking about this incredible tool?
I think that's it. I think you put that beautifully just now. Yeah, thank you so much for this conversation. It's been a lot of fun.
Yes. Well, thanks for clearing the haze around lab decarbonization and understanding the Labs2Zero tool, this incredible benchmarking tool, the AIMS report, what value that can add. And hopefully the listeners check into this further, can enter your building into the software and understand how it can work for you. And then we're looking forward to the conference coming up, the I2SL conference happening in Dallas, October 20th through the 22nd. Thanks for listening to Clear Haze Exchange. New episodes drop every 2 weeks. You can catch Clear Haze Exchange on Apple Podcasts, Spotify, Pandora, iHeartRadio, and more. Let's clear the haze about sustainability and energy efficiency together. Subscribe now and join the conversation.